It seems like every once in a while I'll get an email and they'll say, "Are you the Ed Carpenter that did blah, blah, blah?" And yeah, that's me a long time ago.
Welcome to the Plastisphere, the podcast on plastic, people, and the planet. My name is Anja. Plastic pollution seems to be a pretty new issue, right? In the past few years, the topic has been all over the media. But if you explore the history of science, it turns out that the problem really isn't all that new. Some scientists have been aware of plastic in the ocean for over half a century. So, how was plastic pollution first discovered? And why didn't we hear about it earlier? Over the past year, I spoke to scientists who called attention to the problem long before it was widely discussed. In this episode, I want to share their stories with you, to shed more light on what happened back then and why it took us so long to see the problem. The history of science on ocean plastics really starts in 1972. That year, the journal Science published the first study on plastics in the North Atlantic. This paper formed the basis for much of the research that followed. But the author only put out 2 field studies before he dropped the subject. Edward J. Carpenter is now in his late 70s, still teaching biology at San Francisco State University.
I would say it started about 3 years ago that people started to get interested. And I think it's because finally there's an awareness globally that this is a really big problem, and these plastics are, for the most part, not going away. They don't biodegrade, or if they do it very, very slowly.
Last summer, I met Ed Carpenter when he was on a visit to Berlin. He told me about his time as a young assistant scientist in the early 1970s. Back then, Ed worked at the Woods Hole Oceanographic Institution on the east coast of the United States. The biologist was doing research on the animals and plants living in the North Atlantic.
I was interested in the pelagic sargassum community. This is a brown macroalga that floats on the surface of the Sargasso Sea. This was what Columbus saw when he was traveling across the Atlantic, and he thought he was getting near land, but in reality this organism spends its entire life just drifting on the surface of the ocean.
In the fall of 1971, Ed ventured out into the open ocean on a ship called the Atlantis II. He and his collaborator, Ken Smith, wanted to explore the sargassum and its inhabitants, the fish, the turtles, and other animals. Their ship went out hundreds of kilometers and traveled down south east of the Bermudas. To take samples, Ed towed a Newston net through the water, a special net that skims the sea surface. And he began to observe something unusual.
Every single tow that I took, I was picking up plastic, and all of a sudden, after several tows, I said, "Hey, this doesn't belong out here." Really, the plastics at that time really had only been produced in large numbers since the end of World War II. And so I started to quantify how much plastic is out there, a little bit on what organisms might be growing on the plastic, and what type of plastics there were, and basically how much was out there.
Back in Woods Hole, Ed analyzed his plastic catch. Many of the pieces were in a pellet shape, up to around half a centimeter in diameter. Ed noted that small creatures and algae had settled on the plastic, and he identified a group of toxic chemicals on their surface, polychlorinated biphenyls, or PCBs. He wrote up the results and submitted them to the journal Science, which is one of the most important scientific journals in the world. In the spring of 1972, Science published the study.
The particles are surfaces for the attachment of diatoms and hydroids. Increasing production of plastics, combined with present waste disposal practices, will undoubtedly lead to increases in the concentration of these particles. Plastics could be a source of some of the polychlorinated biphenyls recently observed in oceanic organisms.
Just 2 days after the publication in Science, the New York Times picked up the story. Journalist Boyce Rensberger had spoken to Ed on the phone. On March 19, 1972, he reported that, I quote, "Countless small bits of floating plastic, apparently the refuse of industrial society, have been found drifting over wide areas of a region of the Atlantic Ocean called the Sargasso Sea."
Some were recognizable as cigar holder, syringe needle shield, jewelry, and button snap. The scientists calculated that the plastic bits were spread over a huge area, perhaps several thousand square miles. They speculate that because many plastics contain PCB, polychlorinated biphenyl, as plasticizer, such bits of plastic may be one source of the PCB that has already been found in certain marine organisms.
Just for background, these PCBs were a really hot topic at the time. The chemicals were used in a lot of products, such as electronic equipment, paints, pesticides, and some plastics. In the US, PCB production started in the 1930s, and right away they appeared to be pretty toxic. Some workers at the production plants got skin disease and liver damage, and the chemicals escaped into rivers, the soil, the air, and the ocean. By the time Ed published his paper, PCBs had been found in shrimp, fish, oysters, and birds, as well as in human fat. It became clear that PCBs were nearly indestructible. Today, we also know that they are probably carcinogenic and able to disrupt the hormone system. One use for PCBs back then was plasticizers. These are the chemicals that are mixed into the plastic polymers to increase their flexibility and elasticity. The pieces Ed had found on the open ocean appeared brittle. So, did that mean that the plastics leached these toxic chemicals into the water? Ed told the New York Times that these PCBs were just an incidental finding. He hadn't really checked whether the kinds of plastics he found really contained these chemicals. We're hoping our report will stimulate people who are more expert in this field to pick up on this, Ed told the reporter. Within a month of the publication, Ed got a call, he told me, followed by a visit of a man from the plastics industry. Now, it's important to note that I have not been able to confirm this visit through a second source, so this is an oral history. Here's what Ed told me.
A representative from the Society of Plastics Industry, which I think has a different name today, located in the Midwest, flew out to see me, and basically I got the vibes, so to speak, that he was not too happy about this paper. Because he never said anything positive about it, and really only said critical things, questions, that would try to put me on the defensive.
Ed says he was alone in his office when this man came to see him. He says the man was tall, with dark hair and an expertise in plastics. But he couldn't tell me a name. This was way before laptops and computers, and Ed didn't keep any notes. At the time, he was already working on a second paper on plastic pollution. There were plastic bits floating in the water, not only out on the open ocean, but also along the coast.
I was working on the effects of cooling water going through a nuclear power plant, basically seawater that was used to cool the reactor. And plankton and fish are drawn in with that cooling water. And I was looking at larval fish, and I had what I thought was a fish egg under the microscope, and I squeezed it, and it just popped out. It didn't implode or anything. So I said, what is that? And then I began to notice all these little spheres that ranged from about a 0.5 millimeter in diameter to about 3 millimeters in diameter. So after looking at that plankton tow from eastern Connecticut, which was where that nuclear power plant was, I went back to Woods Hole and threw my plankton net out over the drawbridge and looked at the contents of the plankton tow, and my God, I saw those same little plastic spheres.
This was polystyrene, a polymer that usually sinks, Ed learned. But the tiny pieces were hollow, which made them buoyant. Ed found a lot of them, not only in the water, but also in fish larvae he had collected at the power plant.
About 7 or 8 different species of the, I think, 13 or 14 species of fish that I looked at had those little spheres in their stomachs. And so they were ingesting the spheres thinking that they were eating perhaps another fish egg.
Ed was worried. What the fish had ingested was equivalent to a human eating a bowling ball. He decided to look further into it. At the end of March 1972, he went on a 3-day research cruise along the coast. All along the way between New York City and Woods Hole, he took plankton samples.
And on every single tow that I took, I was picking up those same plastic spheres.
The round pieces looked like the raw material used in plastic production. And again, Ed and his colleagues found PCBs on these pellets, the toxic chemicals. In November 1972, they published their results in the journal Science. And Ed got another industry visit, he said.
The same person came back out from the Society of the Plastics Industry to sort of question my research. And these were the first 2 papers showing that there was plastic contamination in the North Atlantic Ocean.
Ed told me he felt intimidated by these encounters with the man from the industry. But he says it was subtle, nothing direct.
I felt intimidated because, again, he really didn't, he wasn't happy with the research, and I was not a tenured person, so anything negative that would go on as let's say a black mark on my career, especially with the higher-ups at Woods Hole Oceanographic Institution, was going to affect my stability, my future at the Oceanographic.
At the time, Ed was 30 years old, a young assistant scientist. He had just started a family and had 2 kids. He felt he couldn't continue to work on plastics or make a career out of it, he told me. So he dropped the subject.
So that was pretty much, it's like, I don't know, a ghost coming into your life and and having an influence on it and then disappearing. So that was the end of it.
But who was this ghost? Ed couldn't give me a name for this man he described, and he did not have any documentation to back up his claims. But he said that the man had also spoken to some of his colleagues. I wondered if any of them might remember the story or even be able to confirm it. So I called Ken Smith, Ed's collaborator on the research in the Sargasso Sea. He's now at the Monterey Bay Aquarium Research Institute. But Ken said that he couldn't recall any of the story.
That's a very long, long time ago, and I don't remember, so.
After almost 5 decades, how could I find out more about this visitor, this person from the industry Ed says he met? The only other person Ed could think of was his co-author on the second paper. But all I found from him was an obituary. So I stopped looking. Until months later, scrolling through the archive of Science magazine, I happened to find the second paper again. It opened to the second page, and I didn't believe my eyes. Because there was a name. In the footnotes, the authors mention and thank a representative of the Society of the Plastics Industry, Ralph L. Harding. Ralph L. Harding Jr. had been the chief operating officer of the Society of the Plastics Industry during the 1970s. The SPI was a trade association and represented the producers of plastic products and equipment. At the time, environmental concerns were becoming a growing issue, and Ralph Harding seemed very well aware of that. Here are some quotes from an editorial he wrote for the industry magazine Western Plastics.
The really big challenge in this year of opportunity, 1970, is in the area of pollution. Our industry has a critical task ahead. While we are helping to develop solid waste management systems and data on disposal, we have to protect ourselves. We have to get our side of the story across, and we have to be ready to deal with restrictive laws which are already appearing in the legislatures.
Ralph Harding led the SPI through the stormy decade of the 1970s. You can read about it in their Plastics Hall of Fame. In 1972, New York City passed an ordinance taxing all plastic containers. But the SPI successfully defeated the law. Harding represented the industry in hearings at the US Congress on waste management or the flammability of plastics. He successfully fought off major threats to the industry, including bans on PVC or vinyl. When I told Ed about the name in the footnote, he said he totally forgot about it. Yes, he is the person who came to question me after each of the papers were printed, he wrote me. I have tried to find evidence to back up this visit, but I haven't been able to. And I can't talk to Harding to get his side of the story. He suffered a severe stroke in 1981 and passed away in 2000. What I was able to find, though, are documents that shed more light on the exchange between Ed Carpenter and Ralph Harding. They are part of a collection that has been removed from the industry archive. I was able to read them thanks to historian Jeffrey Meikle, who saw them years ago when they were still accessible. According to one of the documents, Ed and Harding spoke on the phone 1 month after the story ran in the New York Times. The next day, Ed typed a letter to Harding about the plastics along the coast. He requested the help of the industry to end the plastic spill. His last paragraph sounded very determined.
We plan to publish the results of our studies. At the time of publication, we would like to be able to state that we have had the cooperation of the plastics industry in locating the source of the polystyrene. We also hope that we will be able to publish data showing decreasing concentrations of plastic spheres in coastal waters.
The same day, Ralph Harding wrote a letter to a representative of Monsanto, informing them about Carpenter's ongoing research. The chemical company not only produced plastics, but was also the only US producer of the toxic PCBs. At the time, the public was already alarmed about their impacts on human health and the environment. Ralph Harding wrote,
Carpenter told me on the phone yesterday that he plans to write a retraction regarding PCBs for inclusion in the next issue of Science magazine. He's learned a whole lot about PCB and wishes he had kept his cool sooner.
As I told you, Ed and his co-author had speculated that the PCBs on the plastics in the ocean came from plasticizers. But they had not studied the plastic polymers in detail to make sure they really contained the chemicals. And here's where the scientists had to make a public correction. When they analyzed the polymers, it turned out that the material most common on the sea surface was polyethylene and could not be the source of the PCBs. So they wrote a note to the journal Science to clarify this.
Polyethylenes are not made with PCBs as plasticizers. Polyethylene often contains low concentrations as contaminants, but these concentrations are so low that it is unlikely that these plastics are a significant source of the PCBs found in the open ocean.
So the plastic material itself did not contain the PCBs. The pollutants had just accumulated on the surface of the plastics. Maybe they had picked up the chemicals in river water. This is a very early description of an issue that would eventually become more and more of a concern. That plastics have the potential to accumulate toxic chemicals and carry them into the food chain. While Ed's correction was still waiting to be published, Ralph Harding was trying to solve the mystery of the pellet spill near the coast. As the executive vice president of the Society of the Plastics Industry, he wrote a memo to all polystyrene producers in the US.
I urge you to take it seriously, to investigate the possibility that one of your plants, or a customer's plant, is involved, and then to let me know your findings and plans for corrective action.
Harding informed the producers about Ed Carpenter's letter. He stressed how important it was for them to comply with the scientists' request for cooperation.
The reverse implications are equally clear. He'll blast us if we don't help him.
Harding described the plastics found in detail and wrote that he would follow up with every recipient of the memo.
In view of the publicity given the Sargasso Sea story, I can visualize the coverage we will get if we don't settle this one. In everybody's best interest, I'd like to be able to tell Mr. Carpenter that we have identified the source of the beads and that full corrective action has already been taken. I'll never have to tell him which company was involved.
It looks like Ed's firm letter to Harding got the industry moving. But by the time Harding wrote his memo to the producers, Ed had already finished collecting the data. In November 1972, when his new paper was published in Science, Ed did not report any decrease in the quantities of plastic along the coast.
Polystyrene spherules averaging 0.5 millimeters in diameter are abundant in the coastal waters of southern New England. The spherules have bacteria on their surfaces and contain polychlorinated biphenyls, apparently absorbed from ambient seawater, in a concentration of 5 parts per million.
That's the story I was able to put together from the old documents. As you can see, the letters and the memo show that Ed Carpenter and Ralph Harding were corresponding about the plastic papers at the time. But the documents say nothing about what happened at Woods Hole in 1972. The archivist at the Woods Hole Oceanographic Institution found no record of a visit of a representative of the plastics industry, and none of Ed's former colleagues I was able to get in touch with said they remembered the story. I also contacted Plastics, the Plastics Industry Association. That's the new name of the Society of the Plastics Industry, or SPI. I asked them if they could comment on Ed's claims of the visits to Woods Hole or provide records to shed more light on his relationship with Harding. They replied that they were unable to assist with my request. I am not the first journalist to ask about this story. In an article for the Center for Public Integrity, journalist Tick Root quoted Ed's claims of an unnamed industry scientist visiting. The Plastics Industry Association sent a statement that said, "We can't speak for anyone who's no longer part of our organization or no longer part of the industry." Despite his pioneering work on plastic pollution in the early 1970s, Ed Carpenter stopped working on the issue and moved on. But his papers in Science inspired other researchers to continue the work. And this way, the science on plastic pollution slowly emerged. I hope you're enjoying this episode. To be able to afford this kind of research and publish it for free, I need your help. I am an independent freelance journalist producing this podcast without a staff position, a big funder, or an advertiser. So if you'd like to hear more or just give back, go to plastisphere.earth/support to help me cover the costs. You can also help new listeners find the show by sharing the podcast with your friends, subscribing, rating, or reviewing it. It really helps the show. And now on to part 2. How did the science on plastic pollution move forward after the Carpenter papers?
Okay, so I did start recording now on my iPhone.
The scientist I reached out to next was Steve Rothstein, a biology professor at the University of California in Santa Barbara. In 1972, he was one of the people who read Ed Carpenter's paper on the plastics in the Sargasso Sea.
And it occurred to me, if this was worth reporting in Science, well, I have evidence that there was probably widespread plastic almost 10 years earlier than when they found it, and also in another part of the Atlantic Ocean.
In 1964, when Steve was a young undergraduate student, he had spent a summer on Kent Island in Canada. Together with an ornithologist, he studied a species of seabird called Leach's petrel. These birds spend most of their life out on the open ocean and catch their food from the surface.
And we found that they had these plastic particles in their stomachs, and even some of it seems to have been fed to their nestlings, because we were studying mainly nesting behavior and nesting biology.
Several of the birds Steve found had pieces of plastics in their body. Note that this was in the mid-60s, At that time, plastic production was still 20 times lower than it is today.
I didn't quite realize the significance of things. I figured, well, there's probably maybe some plastic out there in the ocean and the birds are swallowing it. And I assumed that maybe everyone knows this or it's not that worth reporting that much.
Steve also looked at other petrels that had been collected in another place 2 years earlier. One of these birds had already eaten plastic in 1962. But Steve did not publish his results. He was a young undergraduate student, and he had just started out his career.
It's sort of a funny thing, but I really enjoyed working with seabirds, and I thought they could be used to answer really important biological questions. But I found that I get incredibly seasick because we did do some excursions out on the ocean, and I was miserable the entire time.
Steve did not want to study seabirds if he could not observe them on the ocean. So he switched to birds that live on land, where he wouldn't get seasick. He went on to become an expert on cowbirds and cuckoos.
So the Leach's petrel work really sort of started to fade from my memory to some extent until that Carpenter and Smith paper came along.
8 years after his trip to Kent Island, Steve read Ed Carpenter's paper and revisited his samples. The next year, he got them published in an ornithology journal. To my knowledge, his paper marked the first time the words plastic pollution ever appeared in the title of a scientific paper.
Hello?
Hello, this is Anja speaking. Is that Elizabeth?
It is Elizabeth. Good morning.
Good morning. How's it going in San Diego?
Pretty well. I am now moving to my newly set up recording studio.
Next, I called up Elizabeth Venrick, who was among the first to report plastic trash floating on the Pacific. She came across the issue by accident, literally. Elizabeth worked as an oceanographer at the Scripps Institution in California. In 1972, she and a team of scientists went out into the ocean on a ship that wasn't really up to the task.
It was a coastal ship. It didn't make its own water, so that limited the number of days out. And it was unusually long and narrow. Unusually narrow for the length. It wasn't particularly long. So that in any weather whatsoever, it rolled like a son of a gun.
So the ship wasn't really designed for the open ocean, which meant that the crew had to stop by in Hawaii to resupply with water and fuel.
And when we came back out of Hawaii, we hit the tail end of a typhoon. And this ship somehow took a roll that flooded the generator in the engine room. We had 2 generators, and it flooded and incapacitated one of the generators. As I say, it was a roller. The ship was a roller.
Imagine that with just one generator, the ship was restricted in its power. The scientists could not use the winches to launch and retrieve equipment. So without any research to do, they crossed the calm area that later became known as the garbage patch.
And of course, the weather turned absolutely glorious, as it can only be out there, with just absolutely mirror flat ocean and no clouds and sunshine. And that's why the scientific personnel ended up spending so much time up on the bow, not doing anything.
The ships didn't have the modern gadgets that they do now. There were no cell phones, no laptops. The ships didn't even have satellite navigation. There just wasn't a lot to do. And now the scientists couldn't even do the science.
So we would be, sitting, looking over the side, and then we began to notice these funny things coming by.
The scientists were always on the lookout for pretty glass fishing floats to capture and take home. But on this trip, much more mundane objects floated by as well. A rope, an old balloon, a red rubber sandal, and plastic bottles.
I think we were all surprised But I don't think any of us really understood the implications of what we were seeing. Certainly nobody imagined today's concern. We were still in the age where there was this feeling that we really couldn't ruin the ocean. Now, we were seeing that we could ruin it near shore, or at least very close to shore, but that's why we were out there, was the feeling that the middle of the ocean was still pretty well natural. And, of course, we found that it really wasn't.
Over the next days, Elizabeth and the other scientists were busy with what they called the junk log, a diary of man-made objects floating on the sea surface. The young scientists returned home, and Elizabeth submitted the findings to the prestigious scientific journal Nature.
Certainly the fact that Ed Carpenter and Ken Smith's paper had come out in Science, that gave us sort of a crutch and a little bit of encouragement. And we had a long list of authors, which seemed at that time to be a criteria for publishing in either Nature or Science. So we just went for it. And I was absolutely amazed. It was never reviewed. It was accepted right off the bat.
Looking back, Elizabeth still seems puzzled their paper made it into the famous journal. After all, the whole thing wasn't meant too seriously. If you read her paper closely, you'll notice that even irony and humor shine through. The scientists reported that they were quote-unquote tempted to spend their leisure time on the bow, later, I quote again, succumbing to the temptation to extrapolate. There must be 5 million plastic bottles afloat in the Pacific, Elizabeth and her co-authors estimated. What a number!
You really shouldn't extrapolate to the whole Pacific Ocean from 9 plastic bottles or whatever. But of course the temptation to do it was there.
After the paper on plastics in Nature, Elizabeth continued her research on plankton ecology, later becoming the first woman and marine scientist to serve on the California Fish and Game Commission. In 1972, the plastic in the ocean didn't seem to her like a major threat, more like trash in the park. The scientists who reported plastic pollution in the early 1970s stumbled across it by coincidence. But it wasn't only biologists and oceanographers. A young polymer chemist in Sweden also became aware of the issue. It was Arne Holmström. He was writing a PhD on polyethylene, one of the most common plastic polymers in use today.
I'm born and raised at this island, Smögen, a fishing village on the west coast of Sweden. And a neighbor, just a few years older than me, said, now they are not only littering on the shores or in the nature, but I found plastic sheets when we trawl on the Skagerrak for shrimp.
The Skagerrak is a busy shipping route between the North Sea and the Baltic. The shrimp fishermen from Arne's hometown had pulled up plastic from the ocean floor several hundred meters deep. It did look like polyethylene, the material Arne was studying. When he met a representative of one of the polymer producers, he told him about the plastics on the ocean floor.
But he said that you are the first person in Sweden that is making a thesis on polyethylene, and you shouldn't say something like that. And I blushed. I was so ashamed. Anybody should know that it should stay afloat on the surface and not sink to the bottom.
As you might know, different plastic polymers have different densities, and so some of them sink in seawater while others float. Polyethylene is one of these light, floating plastics, and Arne, the young chemist, felt embarrassed after speaking to the polymer expert. But he wanted to find out more.
So next time I was home, I talked to this neighbor and I talked to my uncle, and they brought me a big sack of material they have collected. And yes, it was, of course, this polyethylene sheets.
How did the floating plastics end up deep down on the seafloor? Arne asked a marine biologist for help, and together they came up with an explanation. The polyethylene sheets had first floated on the ocean's surface, just like they should. But then the material had been degraded by the sun and colonized by algae and small animals. This added weight that must have dragged down the plastic. Arne published his findings in a Swedish journal in 1972. He also decided to share his observations with the international community, so he submitted it to Nature. I asked him why he did not continue to look into plastic pollution. He said he wouldn't have been the right person for that.
I was a chemist and not a biologist or so.
But Arne wasn't the only chemist who became aware of the issue. In 1971, the British scientist Gerald Scott had noted that plastic packaging was polluting isolated places on the shore. He went on to study plastic degradation. And across the North Sea, a young student started to investigate the strange things he found on his hometown's beach.
These are the 74 plastic beads from the beaches of North Holland. I still have them.
This is Hans van Weenen, an environmental chemist from the Netherlands. He is really the one who got me thinking about the history of science on plastic pollution. Hans showed me what he found on the beach decades ago, preserved in a small glass jar. I asked him to open it.
No, I would rather not open this one because it has been kept closed all the time. And the beads also contain substances that might evaporate, like PCBs and DDT and, well, all kinds of persistent organic pollutants are at the surface of these beads. So I'd rather keep it closed. And perhaps one day a scientist might look into that and see what kind of persistent substances are at the surface of these beads. So this is a little historic treasure, really.
Back in 1974, when Hans collected these plastic beads, he studied chemistry at the University of Amsterdam. He had read about the impacts of plastics, and that had brought up memories of his childhood. As small kids, Hans and his friends had found these beads in their bathing suits and on the shore.
I remembered being on the beach and seeing these little white beads on the beach. And we even tried to chew them to see what it was. And it was clearly it was plastic.
At the university, Hans decided to do a survey along the coastline.
And I remember in Wijk aan Zee, I saw a lot of white beads on the floodline between the weeds and really concentrations. And I thought, well, let's draw a square meter and count how many beads I will find on that spot. And in Wijk aan Zee, I remember finding some 800 beads on 1 square meter.
Hans looked into the literature to find out more. To his surprise, similar things had been found on the other side of the Atlantic.
What struck me at a certain time was that in one of those articles in Science, there was a picture. So I got a clear idea of what these beads were like, and they were almost identical to the ones that I found here on the beach. So clearly this was an international phenomenon.
Hans wrote to some of the scientists who had found plastics in other places, and a few wrote back to him. He's kept their letters.
The first one I have is of September 12, 1974, Helen Hayes. I've sent her a letter on September 9th, and I've written to her, obviously, that I was writing a paper on the plastic beads found in my area. And then she says, since we published our short paper, we have not done any more work on plastic pellets. We did receive a report, however, of plastic particles found on the coast of Guatemala. I enclose a paper from Science, which reviews a little on distribution of plastic particles on this side of the Atlantic. It is a recent paper which you may already have, but I thought it might be useful if you hadn't seen it.
Helen Hayes was an ornithologist at the American Museum of Natural History in New York. In 1971, she had found plastic particles in the food pellets of 2 species of birds. The polystyrene particles were entering the food chain, Hayes concluded. She also found plastics near the sewage outlet pipes of factories that manufactured plastics. Another scientist that replied to Hans was A.W. Morris. He was a marine scientist in Plymouth in the UK and reported polystyrene pollution from the Bristol Channel.
27th of September 1974. Since our publication in Marine Pollution Bulletin, we have received a number of letters about plastic particles found around the British Isles, and also received some samples. It almost seems that plastic remnants of all types can be found on any beach if one really searches for them, so even then already.
Hans wrote up a student paper and an article for a Dutch chemical magazine. A local newspaper picked up his story. To do more research on plastic pollution, Hans met with a fisheries expert. But the expert did not seem worried, Hans says.
He told me that it couldn't be a problem because there are many birds that swallow little stones, have them in their stomach to improve their digestion, and these plastic beads couldn't possibly pose any harm.
Hans felt discouraged. He did not get the funding he was looking for. And if the expert didn't think this was worth looking into, maybe he shouldn't take this any further. So like the other scientists I spoke to, Hans moved on to other subjects. After graduation, he went into eco-design, became a university professor and director of a UNEP working group on sustainable product development. But he kept thinking about the plastics. And every once in a while, he went back to the beach with his wife Marja to collect the little beads.
Er is een enorme verscheidenheid aan.
En een korreltje.
Nee.
Ja.
Ja. Granulaat. Een pellet.
After the first plastic papers in the early 1970s, only a few dozen new studies came out about ocean plastics. Most of these reports appeared in specialist publications with a smaller audience. They did not make it into the big journals, Science or Nature. In the meantime, plastic production continued to increase. It grew from 47 million tons in 1976 to 75 million tons in the mid-80s.
I think it's fair to say that not a huge amount happened in the more open literature through the 1970s. So there were the couple of papers at the beginning, and then there was Bill Bourne and a few people wrote the odd thing, but it tended to be small little notes in Marine Pollution Bulletin. There wasn't a lot through the 70s.
Peter Ryan is the director of the Fitzpatrick Institute for African Ornithology. He's the author of 50 peer-reviewed papers on plastic pollution. In his Brief History of Marine Litter Research, he traced the development of the field.
Bob Day, towards the end of the 70s, did a really nice piece of work looking at plastic in seabirds in Alaska, but it was never really published in good places and really only came out in the proceedings of the first Marine Debris Conference. So, I think it's fair to say that for a decade after those first couple of papers, not a lot happened.
Peter started to investigate plastic pollution in 1984, looking at how it impacts seabirds when they eat it. At the time, there weren't many people working on plastics. But this soon changed with a series of international conferences. There was increasing worry about the big pieces of trash in the oceans. Seals, turtles, fish, and whales were harmed by fishing gear, cargo nets, or plastic packing bans. So the U.S. Marine Mammals Commission and the Fisheries Service initiated the so-called marine debris conferences.
I think the 80s were quite a dynamic period for plastics research. There was a lot of new people coming in, new perspectives, and setting new agendas. And the focus was already shifting away from let's quantify the problem to let's start to tackle the problem. And that really became the focus of the third conference, which was held in Miami, where we were of the opinion that we demonstrated enough of a problem and now we should focus on mitigation. The nice thing about working on plastics is it is a completely avoidable problem. It's not like tackling climate change where you're asking people to make really difficult behavioral changes. You're actually just asking them to dispose of plastics properly. And so, at least in theory, it should be a fairly simple problem to solve. Of course, 20 years later, we realize it's not a simple problem to solve, but that's just, maybe we were a bit naive in the 1990s when we thought that it would just be a simple case of changing people's behavior.
In 1990, Peter and Colleen Maloney already used the term microplastics to describe the industrial pellets and small plastic fragments they found on the beaches of South Africa. By that time, world plastics production had reached 100 million tons, which is a fourth of what's produced today. Sure, some steps had been taken to stop trash from reaching the oceans. For example, ships were banned from throwing plastics and garbage overboard in the 80s, and there was recycling. But that couldn't really stop the growing pollution at sea. So when a captain crossed the Pacific in 1997, he rang the alarm.
The next sort of big event was really I think the work of Charles Moore in really starting to describe the North Pacific garbage patch, and that was a concept that I think got quite a lot of traction with the broader public, the idea that there was this floating island of plastic in the North Pacific. That really captured the popular imagination, although of course there was no island, but that's another story. And then I think Richard Thompson's work on microplastics, those two things happening more or less the same time at the end of the 1990s into the 2000s, I think that's what really kind of rekindled interest in plastics. And then from there it's just been kind of an ever-increasing amount of stuff coming out and more people getting on the bandwagon.
From the early 1980s, research on plastic pollution slowly moved towards becoming a scientific field. But the real push came from outside the science, when environmental NGOs, such as Algalida, the nonprofit founded by Charles Moore, brought the issue into the limelight.
Even when I started, people kind of were like, "You're going to work on what? Plastic ingestion in birds? Why are you doing that? Why don't you work on something, sort of more relevant, I guess?" Now everybody and their auntie works on plastics.
Plastic production continues to rise. In the last 2 decades alone, more plastic was produced than in the entire second half of the 20th century. Along with the steep rise in production, more and more trash is accumulating in the environment. Today, the waste issue has become impossible to ignore. But plastic pollution was discovered much, much earlier. In the 1970s, Ed Carpenter found plastic floating in the Atlantic, and Steve Rothstein showed that birds had been swallowing it even a decade earlier. Elizabeth Venrick saw bottles drifting by in the Pacific and started a junk log. Arne Holmström reported polyethylene on the ocean floor from Sweden, and Hans van Weenen found plastic beads on his hometown's beach in the Netherlands. They weren't the only ones. US fisheries scientists showed that plastic particles were widespread in surface waters of the northwestern Atlantic. And even far down in Antarctica, near a research station, scientists reported litter on the seafloor. I found a pretty prescient quote from Ed Carpenter in a small local newspaper. Again, this is from 1972.
Plastics have only been produced in large quantities since World War II. And to me, it's kind of frightening that within 25 years, the middle of the ocean could be littered with these plastics. It kind of makes you wonder, what will happen in 50 or 100 years?
The first 50 years have almost passed now. But back then, it was all just the beginning. In 1973, the plastic bottle was patented. Coca-Cola introduced them in 1978, the year I was born. The next year, the production of plastics exceeded that of steel. Plastics were taking over the world.
Well, I knew that I really couldn't base my whole career on plastics, although probably, in retrospect, I could have.
Ed Carpenter became an expert in plankton science. One day in 2010, he attended a big ocean sciences meeting in Portland, Oregon. He heard there was going to be a special session on plastic pollution, so he went to the meeting and sat down to hear the talks. One of the scientists presented the first studies on plastics in the Atlantic Ocean. And Ed was astonished. The paper on top of the list was his own.
I reread those papers that I wrote in 1972, and I was very happy with them. I felt that they really covered a lot of aspects of plastic pollution, and to me, they were ahead of their time, and I was proud of them. But I feel that I should have kept going in that area. And I think that there's a lot more that I could have pointed out. And I could have been an advocate, and perhaps instead of waiting 50 years, I could have gotten the field moving a lot faster to deal with this problem.
Though Ed did not continue his own work on plastic pollution, he did inspire others to follow up on it. Not only the scientists of the 1970s. According to one of his former colleagues, he also suggested the collection of what would later become one of the most famous data sets in plastics research. And to close the circle, the scientist who had mentioned his paper at the conference was the one who had analyzed these samples. I asked Ed why he decided to tell his story after such a long time.
I think it's partly because people ask, but there's always some historical aspects to it. How did we get from here to there? And I think, if I have any lesson here, it's that you should stick to your guns and believe in what you think is important, and follow your lead, follow your nose on that. I regret that I didn't.
This was The Plastisphere with Ed Carpenter, Ken Smith, Elizabeth Venrick, Arne Holmström, Hans van Weenen and Peter Ryan. Thanks to all of them for taking the time to record with me and share their memories and insights. Adam Huggins read the writings of the young Ed Carpenter, and Mendel Skulski lent his voice to the words of Rolf Harding. Together, Adam and Mendel produced the podcast Future Ecologies, where they explore the shape of our world through ecology, design and sound. It's one of my favorite shows, so make sure to check it out. Quotes from the New York Times were read by audio producer Terrence Mickey. In his wonderful Memory Motel podcast, Terrence finds the drama in what we want to remember or forget. Listen to it wherever you find your podcasts. Plastisphere is an independent project created, researched, written, and produced by me, Anja Krieger. I publish the podcast in the spirit of the gift economy. You can help me fund future episodes via PayPal, Patreon, or Riff Reporter. Go to plastisphere.earth/support to find out more. I really appreciate any contribution you can make. The theme song is by Dorian Roy and all other tracks by Blue Dot Sessions. Cover art by Maren von Stockhausen and recording of The Leech's Petrol by Ingrid Paulet. The sound of the typewriter was published by Ila Akisto, and the beach sounds in Hans' story were by Klangbelt, both from freesound.org under a Creative Commons Attribution 3.0 license. This episode would not have been possible without the people at the Max Planck Institute for the History of Science. They invited me for 2 months as a journalist in residence and allowed me to dive deep into the past. Huge thanks to Hans-Jakob Ziemer, Stephanie Hood, Jürgen Renn, Christoph Rosol, the Anthropocene Group, and all the researchers who I was fortunate to meet there. I am especially thankful to MPI's excellent library team, in particular Matthias Schwert, Ruth Casantini, and Ellen Gaske. A big shout out to Melanie Bergmann, Lars Guto, and Mine Tekman at the Alfred Wegener Institute for Polar and Marine Research. They run the scientific database that helped me find the studies you heard about in this episode. Check it out at litterbase.awi.de. Also, huge thanks to Cindy Gearhart at Holland and Knight for legal counsel on parts of this podcast. Some really wonderful friends and colleagues provided feedback and help for this episode. Thank you, Tim Howard, Deborah Blum, Christian Schwegal, Louisa Beck, Brooke Watkins, Caradwin Cornelius, Eva Vandergiesen, Ines Blasius, Rebecca Altman, and Peter Spork. Special thanks to the people at Netzwerk Recherche and the Schöpflin Foundation. I'd also like to thank Erica Serino, Tick Root, Marcus Eriksson, and Kim de Wolf for writing about the history on plastic pollution, as well as Chris Rose, Linda Godfrey, John Farrington, Carol Levendelaw, Gilbert Rowe, Bruce Burns, W.R.P. Bourne, the archive at Woods Hole Oceanographic, the staff at NOAA, the University of Auckland, and the former colleagues of Ed Carpenter who replied to my questions. Last but not least, thank you for listening. I'm sure there are more stories on the history of science. So if you know anyone who worked on plastic pollution early on, I'd love to hear about them. You can email me, Anja, at plastisphere.earth, and I'm at PlastispherePod on Twitter, Instagram, and Facebook. Stay tuned, be well, and see you soon.